Good morning. My name is Patrice Senez, and I'm going to present you the score. The score is the Senez cold original rotative engine. So you see this in movement in an animated video, but let me explain to you all its principles. So first of all, I'm born in 1967, the 6th of January, and I thought about this engine since I was 19. I dreamed about it and thought it already exists. So the score, the Senez cold original rotative engine from Patrice Senez, has some principles from the mechanic of fluids. Very interesting. You just saw the animated video, and I will send you this presentation, and you have the video right there inside the PowerPoint. Its patent in France, the one in France, is at the ENPI. So you go to enpi.fr, you go to database, base de brevet, you select this. Once you select this, you have base de brevet, database of patents. You have this page, you go and scroll to the bottom, and access to the service, accéder au service. You will find this page, you just search for Senez Patrice, and you will find the description, and you have a tab Documents. You have a PDF in black and white. I'm going to show it to you in color. And the patent is FR 2990723. First, what is that cold original rotative engine? Looks like a drum, like a washing machine. It is washing gas and air. Let's see what's inside. First, you have some what I call butterflies. Two types, female type and male type. So those are intricated one into each other. So here's the view of the male one, and here's the view of both intricated on this side. Another view from the other side, and in stage what we call X. There's two kind of stage V and stage X. So what is the mystery of this? Those axes that are encapsulated, the axes are of course linked to every blades and butterflies. So we have 4 chambers. Chamber 1, chamber 2, chamber 3, chamber 4. We're going to take an arbitrary rotations, clockwise, but when it's clockwise, the explosions happen to be counterclockwise. So we have 4 colors. Mixture, in blue, air and gas. Compression, in red. The spark, this is a red time, a flag time. Explosion, in yellow. Exhaust, in gray. So we saw the number 1 in compression. After the spark, it's in pre-explosion. It starts to expand because of the dilatation of the mixture. Exploded, burning. This one is in full V, full explosion. It's pushing against this blade, which is pushing there and putting the chamber before, number 4, in full compression. Chamber 1 is in pre-exhaust. The gas is burned. We need to eject it now. And here, full V, ready to go out. Once that, we have a new cycle with pre-admission. We take the intake in, full intake, we maximize it, we take a lot of it, and pre-compression, and we go back to that stage, similar stage, chamber 1 in full compression. So we imagine that the engine was already running. It's easy to start it. Doesn't need a heavy duty starter. Just rolling it and boom, boom, it starts. So let me show you backwards from the principles. 1, 2, 3, 4, 5, 6, 7, 8, 1. So this is the idea, right in movement with 4 chambers. So we have the V0. In V, full, we start in V, okay? That's arbitrary, but it's an example. After the V0, we have X0, which is the important chamber. After the X0, we have V1. After V1, we have the X1. So what we get next? X1, explosion. Ready for V2, which going to be now and become X2. And from the X2, you have the V3. From the V3, you have now one more, X3. So 1, 2, 3, 4. I start at 0 like in computers. And we have a new cycle beginning. So this is a butterfly. This is another butterfly. Inside you have the blades in red and blue, clear blue and yellow. This is the other cut, the other stage. So you imagine that that blade is not that straight, straight. You can imagine a curve going towards the rotation. But this engine has, for the easy explanation, just 4 chambers. You can easily imagine 8 chambers. Why? Because this engine has a lot of power, a lot of torque, and using the full power of the mixture. So, to soften it, you multiply. You multiply the chambers by a multiple of 4. A 2 cycle is feasible. And I'm working right now on what I call the super loose. That means each blade is loose, and it's the gear that controls everything. So you have to imagine this in 3D, rotating. The rotation and of course the axis encapsulated, and the blade. Of course, at the top of the blade, what you have is a piece of metal, for example, that is loose and moving. When the engine has a lot of force, centrifuge force, and it's pushing against the drum and sealing the chamber. The different shapes. We can easily imagine a shape of a camembert, what I call the cheese, with the intake from the outside and the exhaust on the side. Or the total opposite, with the intake on the side and the exhaust outside. Here's the cut. Still, the blade in V. This is the spark. You have the large intake, the small exhaust, the blades. Here's another view. Exhaust. The spark is right there. Intake, exhaust, axis. An exploded view. Another view with the drum exploded. Another view of the exploded view. The blade here in exhaust. And here are the axes encapsulated. Of course, each axis is linked to the blade. A cut, another cut. And here's the full drawing. So this is how it's registered right now in France. The cold rotative engine. The idea is